That means we have to rotate the rotor by external agent. Are you able to understand this?
Yes, sir.
Okay. So that external agent is induction motor. For that reason, we couple a small induction motor. We call it as pony motor. They're all fractional HP motors. Okay. Their job is to just rotate the rotor, nothing else. So very small fractional HP, maybe 0.5 HP, less than 1 HP. They're called pony motor. So they're coupled with what it means is we have a long shaft. On one side of the one end of the shaft is connected to the rotor of the synchronous motor. The other end is connected to the induction motor. Okay. So what we do is we first run the induction motor, then the induction motor in turn will rotate the shaft, which in turn will rotate the rotor of the synchronous motor. ಗೊತ್ತಾಗ್ತಿದೆಯಾ?
Yes, sir.
Okay. Note here that the number of poles of induction motor should be less than the synchronous motor. That is an important requirement you have to fulfill here. When we choose induction motor for the purpose of starting, number of poles in that induction motor should be less. Otherwise, what happens is it will never be able to achieve synchronous speed of the synchronous motor. Okay, is it clear?
Yes, sir.
This is because induction motor always has a speed less than synchronous speed. I repeat, induction motor will always have a speed less than synchronous speed. Matter of fact, that is the reason why it's called asynchronous motor.
Yes, sir.
With that, is it clear? A synchronous motor speed is always equal to synchronous speed, whereas induction motor speed is always less than synchronous speed. For that reason, it is grouped under asynchronous machine. And in case if induction motor speed becomes equal to synchronous speed, it will stop working. Is it clear?
Yes, sir.
So to make the speed equal to synchronous speed, okay, the speed of the number of poles must be less than the number of poles in the synchronous motor. Okay, so that's important. For it to become equal to synchronous speed of the synchronous motor. So its own speed has to be increased. And the artha ಏನು ಅಂದ್ರೆ induction motor speed has to be increased so that that becomes equal to synchronous speed. Otherwise, the synchronous motor will not run at synchronous speed. ಗೊತ್ತಾಗ್ತಿದೆಯಾ ಇದು?
Yes, sir. Yes, sir.
So
Yes, sir.
for that to happen, we have to have induction motor to we have to have lesser number of poles in the induction motor, so that if you use the equation n is equal to 120 f by p, lesser the number of pole, your speed gets increased. So the number of pole in induction motor should be less than that in the synchronous motor. So that's the important one. Now, after the rotor of synchronous motor is brought to the synchronous speed, that means we apply voltage to induction motor that will rotate the shaft at synchronous speed, and in turn the rotor of the synchronous speed also rotates at the synchronous speed. Then we switch on the DC supply to the rotor. So then only we have to excite the synchronous motor. Is it clear?
Yes, sir.
Andre, at that point only magnetic field becomes on. Magnetic field gets established. Till that point, no magnetic field. After that, we simply decouple the induction motor from the synchronous motor shaft. That's the concept here. Any doubt?
No doubt, sir.
Right. And second method is instead of an induction motor, we use a DC motor. So it is similar to above method with a slight difference between the two. A DC machine is coupled to the synchronous motor. DC machine works like a DC motor initially and brings the synchronous motor to synchronous speed. Once it achieves the synchronous speed, the DC machine works like a DC generator and supplies DC to the rotor of the synchronous motor. You see how beautiful it is? Any doubt here?
No, sir.
That means what advantage what we derive when we use a DC machine in place of induction motor is that the DC machine initially works as a motor because we would have applied voltage to it. And once it rotates the synchronous motor, the synchronous motor would drive the DC machine as a generator, and now it becomes a generator developing voltage. And that can be used to excite the field of the synchronous motor. ಗೊತ್ತಾಯ್ತಾ ಇದು?
Yes, sir.
Right. Then the other approach is using damper windings. Here, motor is first started as an induction motor, then it runs as a synchronous motor after achieving synchronous speed. Now the question is how to make synchronous motor to operate as induction motor. That's what we have to do here. We have to make synchronous motor to operate as induction motor.
Sir, rotor speed must be less than stator speed, sir.
Okay. Anything else?
So that field windings also should be less, sir.
There should not be any field current. That is the fundamental difference. I told this yesterday. Remember?
Yes, sir.
Fundamental difference between a synchronous motor, induction motor is that in induction motor, we don't supply DC to the field circuit. In synchronous motor, we do supply. So that means we don't give any DC excitation to the field and we apply voltage to the stator. When I do so, the same synchronous motor starts as an induction motor. Is it clear?
Yes, sir.
Okay. Then what we will do, these damper windings are used. Yen damper winding andre are additional windings consisting of copper bars placed in the slots in the pole faces. So we have the pole faces in the synchronous motor. So there in those slots, we keep or we place these windings as additional windings in addition to the main windings. The ends of the copper bars are short circuited. Why we have to do this? ಇದನ್ನು ಹೇಳಿದ್ದೇನೆ ನಾನು. While discussing about the principle of operation of induction motor and synchronous motor, I compared how the two motors work. Can you recall? Vaibhav, Chandramohan, Bharati, and others. You see, in your class of about 60 plus, I'm able to remember only few names. Can you tell me why? Hello? I'm audible?
Yes, sir. Yes, sir.
Yeah, why only few names I remember? That is true with any teacher. Can you guess? Sukrit?
Sir?
ಕೇಳಿಸ್ತಾ ಹೇಳಿದ್ ನಾನು.
No, sir. Can you repeat it, sir?
Out of 60 plus students in your class, I'm able to remember only few. Why?
Like they want to interact more, sir.
Yes, that means I want all to interact. A teacher should be able to remember everybody in the class. That's possible only when everybody interacts. And that is most important, I should say, attribute from any student. Whether he's wrong or right, that doesn't matter, but you have to interact. And you should consider interaction as an opportunity. Okay. Chandramohan, can you tell me why the copper bars are to be shorted?
Sir, don't know, sir.
Sukrit ಅಥವಾ ವೈಭವ್, can you try? ನೆನ್ನೆ ಹೇಳಿದೆ ನಾನು, ಭಾರತಿ or anybody in your class?
So like there shouldn't be any field inside the damping winding.
ಇನ್ನೊಂದ್ಸರಿ ಹೇಳೋ.
There should be no field inside the damping windings.
ಅಲ್ಲ. Any other answer?
Sir, to ensure that the rotor is closed, sir.
Correct, very true. Why? You are right. Why it should be
Sir,
closed?
we want stator and rotor flux, no, sir.
Yeah, absolutely correct. And that is the fundamental difference between the two as far as the operating principle is concerned. In case of synchronous motor, we externally excite the field by giving a DC supply. But induction motor, we don't give any supply to the field, but that field gets excited by the induction process itself. That's why it takes the name induction. Are you getting this point?
Yes, sir.
Yes, sir.
So when I apply a voltage to the stator, I'm talking of induction motor. A rotating magnetic field is produced. That is true with the synchronous motor as well. But in addition to that, what happens in induction motor is this rotating field will induce voltage in the rotor also. And that will drive a current only if the rotor circuit is closed. For that purpose, the copper bars are short circuited. So that means the field circuit gets closed, that is the rotor circuit is closed, and the rotor field is established, and then the two fields interact with each other, constituting a torque that will rotate the rotor. And that's how the induction motor operates. Is it clear?
Yes, sir.
So that is the job of the damper windings. They make the rotor circuit closed and see that a torque is produced, which in turn will rotate the rotor. That means I intentionally or deliberately make synchronous motor to run as induction motor initially. Okay, now?
Yes, sir.
Right. When three-phase power is supplied to the motor starts running as induction motor at a speed below synchronous speed. Obviously, because induction motor has to run at a speed below synchronous speed. After some time, DC supply is given to the rotor of the same machine. The motor gets pulled into synchronism after some instant and starts running as synchronous motor. So though it was running earlier at a speed lower than synchronous speed, since we now give an additional excitation to the field that will pull this to the synchronous value, now the same machine works as synchronous mode. Any doubt here?
No doubt, sir.
No doubt,
When the
sir.
motor when the motor reaches synchronous speed, there is no induced EMF in the damper windings. ಏನಕ್ಕೆ ಅಂದ್ರೆ the relative speed ಇದ್ರೆ ಮಾತ್ರ induced EMF. When there is no relative speed, when the relative speed becomes zero, because both will be running at the same speed. Both ಅಂದ್ರೆ ಯಾವುದು? Your stator magnetic field and the rotor speed, they will be running at the same speed. That being the case, there is no relative movement between the two or motion between the two, hence no induction, hence no EMF. So when the motor goes to synchronous speed, there is no induced EMF in the damper windings anymore, and hence they don't have any effect on the working of the motor. That means the damper winding idru onde bitru ondene, it will not give any excitation to the field. Now the excitation is only from an external supply. Okay na?
Yes, sir.
And this is the most commonly used technique to start synchronous motor. Any doubt here?
No doubt, sir.
ನೋಡಿ, ಇದು ಈಗ ಹೇಳಿದ್ದೆ ನಾನು, that is the concept of the cage induction motor. Cage induction motor ಅಂದ್ರೆ there are two types of induction motors. One is cage, the one what I explained, wherein we short circuit the rotor. Okay? ಇನ್ನೊಂದು ಸ್ಲಿಪ್ ರಿಂಗ್ ಇಂಡಕ್ಷನ್ ಮೋಟರ್ ಅಂತ ಇನ್ನೊಂದಿದೆ. ಅಲ್ಲಿ we don't short circuit directly, but what we will do, we will make electrical connection on the rotor through slip rings. That's one more approach here. Starting induction motor using slip ring, starting synchronous motor using slip ring induction motor. Here we connect one external rheostat in series with the rotor. The motor is first started as slip ring induction motor. The resistance is gradually cut off as the motor gains speed. When it achieves near synchronous speed, DC excitation is given to the rotor and it is pulled into synchronous. Then it runs as synchronous motor. So here the procedure is a bit different. What we'll do, we'll connect an additional or external resistance in the field circuit, that's in the rotor circuit, through the slip rings. Slip ring, can you tell me where the slip rings are mounted? Where the slip rings are mounted?
Prime movers.
On the shaft. On the shaft. That means as the shaft rotates, slip rings also rotate at the same speed. Therefore, the relative motion between the slip ring and the shaft is zero. ಗೊತ್ತಾಗ್ತಿದೆಯಾ?
Yes, sir.
And that is an important requirement if at all I have to do any electrical connection in the rotor circuit. So that's why we go for slip ring induction motor. I cannot do such thing in a cage motor, because cage motor, it is completely closed. Illi, it is not closed. It is closed through slip ring. ಗೊತ್ತಾಗ್ತಿದೆಯಾ?
Yes, sir.
ಅಷ್ಟೇ. So that is the difference. That's about the starting methods used in case of synchronous motor. Now we'll come to the next important article. Like it doesn't mean that the articles we have discussed are not important, right?
Yes, sir.
Every article we discuss, a teacher discusses, is important. Right. Now, synchronous condenser. Have you heard of this word condenser anytime earlier?
Sir, you told it is capacitor, sir.
Yes, ಅದು ಸರಿ, ಕೆಪಾಸಿಟಿ ಸರಿ. ಇದು ಕಂಡೆನ್ಸರ್ ಅನ್ನೋದು ಆಟೋಮೊಬೈಲ್ ಇಂಡಸ್ಟ್ರಿನಲ್ಲಿ ತುಂಬಾ ಪಾಪ್ಯುಲರ್ ವರ್ಡ್. Okay, though it means capacitor for electrical engineers, automobile ಇದರಲ್ಲಿ this condenser is a very important part. Of course, that condenser is different. Okay, but here electrical engineering condenser is a capacitor. Right. Now, can you what is this curve we have already discussed? What is the name of this characteristic?
Inverted V, sir.
ಏನಪ್ಪ?
V curve, sir. V curve.
V ಕಣ?
V curve. Yes, sir, V curve. Sorry.
V. ಅಂದ್ರೆ ನೀನು ಉಲ್ಟಾ ನೋಡ್ಬಿಟ್ಟೆ ಅಂತ ಕಾಣುತ್ತೆ ಅಲ್ವಾ ವೈಭವ್?
Yes, sir. Yes, sir.
Okay, this is a V, and towards the right is over excitation. Along x-axis we have the field excitation. Y-axis ಏನದು? What IS stands for? IS.
synchronous current.
ಸಿಂಕ್ರನಸ್ ಕರೆಂಟ್ ಅಂತ ಎಲ್ಲಾದ್ರೂ ಇದೆಯಮ್ಮ?
Stator current, sir.
ಸ್ಟೇಟಾರ್ ಕರೆಂಟ್, ಕರೆಕ್ಟ್. ನಾ ಹೇಳಿದ್ದೀನಿ ಸ್ಟೇಟಾರ್ ಅಂದ್ರೂ ಒಂದೇ, ಆರ್ಮೇಚರ್ ಅಂದ್ರೂ ಒಂದೇನೆ. ಒಂದೇ. I will be back in 1 minute. Yeah. Sorry, students. I'm back. Hello? Yeah, shall we continue?
Yes,
sir,
sir.
yes, sir.
Yeah, like what I was telling, ಹೇಳ್ತಿದ್ದೆ ಅಲ್ವಾ?
About condenser, sir, in automobile industry.
Correct. That condenser is different, but here condenser means it is capacitor. Okay, yeah, and okay, this is weaker stator current. Stator current ಅಂದ್ರೆ ಒಂದನೇ, armature current ಅಂದ್ರೆ ಒಂದೇ. Okay, towards right is the over excitation. Over excitation ಅಂದ್ರೆ ಯಾವ PF? Lagging ಆ leading ಆ?
Leading PF.
Very good, leading. Under excitation?
Lagging PF, sir.
Critical excitation? Critical excitation?
Sir, lagging, sir.
ಅಲ್ಲ, UPF ಇದೆ critical ಅನ್ನೋದು. ಇಲ್ಲಿದೆ ನೋಡು.
Yes, sir. Yes, sir.
Right. ನೋಡಿ ಇಲ್ಲಿ ನೋಡಿ, ಇದು he has given a set of V characteristics for different power delivery. ಇದು the one which touches the x-axis is no load. ಗೊತ್ತಾಗ್ತಿದ್ಯಾ?
Yes, sir.
And as we go up, the load is increasing, and the topmost one is the full load. Okay,
Yes, sir.
so andre V characteristic is valid at any load anta artha. Okay, now can we see this diagram at the middle? Kantidyಾ idu?
Yes, sir.
Okay, now we have the okay, ಇಲ್ಲಿ ಒಂದು ತಪ್ಪು ಆಗಿದೆ. ಏನು ಅಂತ ಇಲ್ಲ, ತಪ್ಪೇನಾಗಿಲ್ಲ. ಅಲ್ಲಿ ಯೆಲ್ಲೋ ಲೈನ್ ಕಾಣ್ತಾ ಇಲ್ಲ ಅಲ್ವೇನಾ?
Yes, sir. ಸ್ವಲ್ಪ ಬ್ಲರ್ ಆಗಂಗಿದೆ.
ಬಹಳ ಡಿಮ್ ಆಗಿದೆ. ಸೊ ಬೇಸಿಕಲಿ ಇಟ್ ಈಸ್ ಎ 3-phase supply. One supply is given to a 3-phase load, and please note, when I say 3-phase load, generally what it means? Generally
Star connected load.
ಅಲ್ಲ, think ಮಾಡು. ನಾ ಹೇಳಿದ್ಲಿ ಇದನ್ನ. ಅಥವಾ ಸುಮ್ಮನೆ ಲೋಡ್ ಅಂದ್ರೆ ಜನರಲಿ ಏನು?
Current.
ಕರೆಂಟ್, ಸರಿ. what type of load it is? Type
AC.
ಏನಮ್ಮ?
AC.
ಕೇಳಿಸ್ತಿಲ್ಲ ಕರೆಕ್ಟಾಗಿ. ಇನ್ನೊಂದ್ಸಲ ಹೇಳು.
AC, sir.
ಅಲ್ಲ, ಸರಿ, AC ಅಫ್ಕೋರ್ಸ್ ಇಲ್ಲಿ ನಾವು ACನೇ ಹೇಳ್ತಾ ಇರೋದು, ಕರೆಕ್ಟು. ಬಟ್ when you see, we have 3 types of loads: resistive, ಇಂಡಕ್ಟಿವ್, ಕೆಪಾಸಿಟಿವ್. ನಾನು ಸುಮ್ಮನೆ ನಮ್ಮ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಅಲ್ಲಿ ಲೋಡ್ ಅಂತ ಹೇಳ್ಬಿಟ್ರೆ ಇಟ್ ಈಸ್
Inductive load, sir.
ಇಂಡಕ್ಟಿವ್ ಲೋಡ್. ಏನಕ್ಕೆ ಅಂದ್ರೆ 90% ಆಫ್ ದಿ ಲೋಡ್ಸ್ ಆರ್ ಇಂಡಕ್ಟಿವ್. ಗೊತ್ತಾಯ್ತಾ?
Yes, sir.
ಸೊ ಈ 3-phase ಲೋಡ್ ಅನ್ನೋದು ಇಟ್ ಈಸ್ ಇನ್ವೇರಿಯಬಲಿ ಇಂಡಕ್ಟಿವ್ ಲೋಡ್. And 3-phase supply is also given to synchronous motor. Now I am operating this as a capacitive load. ಗೊತ್ತಾಗ್ತಿದ್ಯಾ?
Yes, sir.
How I can operate this as a capacitive load? How synchronous motor is operated as a capacitive load? ಹೇಳಿದೆನಲ್ಲ.
Sir, any current greater than field current is given, sir.
ಅಂದ್ರೆ ಎನಿ ಫೀಲ್ಡ್ ಕರೆಂಟ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಕ್ರಿಟಿಕಲ್ ಫೀಲ್ಡ್ ಕರೆಂಟ್ ಅಂತ ಹೇಳ್ಬೇಕು.
Okay, sir.
Or when it is over excited. Over excite ಆದ್ರೆ then the motor will operate at a leading power factor. So that is what we have shown in the phasor diagram. ನೋಡಿ ಈಗ ಫಸ್ಟ್ ಅಪ್ಲೈಡ್ ವೋಲ್ಟೇಜ್ V which is common to both the loads, ಒಂದು inductive load as well as synchronous motor load, and assume that we have only inductive load, then the current taken by that is shown as IL. That will lag because it's a lagging load, lag by a larger value theta L with respect to V. And the current taken by the synchronous motor leads the applied voltage by a certain angle theta M. That's also shown here. Therefore, the effective current or the resultant current is I, that will lag V by a smaller angle. ನೋಡಿ ಇಲ್ಲಿ ಗೊತ್ತಾಗ್ತಿದೆ ಅಲ್ಲಿ.
Yes, sir.
Which means the power factor has decreased or increased.
Lagging loads.
ಸರಿ, ಪವರ್ ಫ್ಯಾಕ್ಟರ್ ಜಾಸ್ತಿ ಆಯ್ತಾ ಕಮ್ಮಿ ಆಯ್ತಾ?
ಜಾಸ್ತಿ ಆಯ್ತು ಸರ್.
ಜಾಸ್ತಿ ಆಯ್ತು. ಲೋಯರ್ ದಿ ಆಂಗಲ್ ಬಿಟ್ವೀನ್ ವೋಲ್ಟೇಜ್ ಅಂಡ್ ಕರೆಂಟ್, ಹೈಯರ್ ದಿ ಪವರ್ ಫ್ಯಾಕ್ಟರ್. ಕರೆಕ್ಟಾ?
Yes, sir.
This is what effectively the synchronous motor, what it does in a network. Okay, and this kind of operation is called synchronous condenser. Like capacitor bank, we can use overexcited synchronous motor to improve poor power factor of a power system. The main advantage of using synchronous motor is that improvement of power factor is smooth. ಇದು ಬಹಳ ಮುಖ್ಯ. ಇದು when I compare capacitor, improvement of power factor using capacitor with improvement of power factor using synchronous motor, advantage ಏನಪ್ಪಾ ಅಂದ್ರೆ synchronous motor will improve power factor smoothly ಅಂದ್ರೆ it's not a stepwise improvement alla, a curve wise improvement, and that is absolutely good. When a synchronous motor runs with over excitation, it draws leading current from the source. We use this property of the motor for the purpose of improving power factor. So ಗೊತ್ತಾಯ್ತಲ್ವಾ ಇದು?
Yes, sir.
And whatever I have told, how the power factor improvement takes place, another he explains in this paragraph, so that is okay, that we have done. The synchronous condenser is a more advanced technique of improving power factor than a static capacitor bank, but power factor improvement by synchronous condenser below 500 kVAR is not economical. So ಅಂದ್ರೆ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಈ ನಮ್ಮ reactive power ಇದಲ್ಲ, if it is more than 500 kVAR, then only we should use synchronous motor to improve power factor. If it is less than 500, capacitor bank is better from the point of economics. For major power network, we use synchronous condensers for the purpose, but for comparatively lower rated systems, we employ capacitor bank. ಗೊತ್ತಾಗ್ತಿದೆ ಪೇದ?
Yes, sir.
ಅಷ್ಟೇನೆ. And ಡ್ರಾಬ್ಯಾಕ್ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಮುಖ್ಯವಾಗಿ this being a motor, a dynamic system, lot of noise continuous ಆಗಿರುತ್ತೆ. So the environment will not be silent. Otherwise, the synchronous motor or condenser is a good technique to improve power factor. Okay, I think we'll stop here. We are left with one more article. Of course, we have other articles also. Those articles I'm going to like little later I will take if time permits. Otherwise, you have to manage. Okay, maybe another 2-3 articles you have to manage, and all other things we have covered. Okay, And this I want to cover. So this I will do tomorrow. Tomorrow anytime, can you give me 1 hour slot? ಯಾವ ಫ್ರೀ ಇದ್ರೆ ಬೆಳಿಗ್ಗೆ ನಾಳೆ ನೀವು?
ಸರ್ ಹೇಳ್ತೀನಿ ಸರ್ ನಿಮ್ಗೆ.
ಓಕೆಪ್ಪ, ಸರಿ. And the questions for the event will be sent by night.
Okay, sir.
Okay, pa. Right. Thank you. Bye.
Thank you, sir. Nice, sir.
Right.
Thank you,
Thank you,
sir.
sir.
Thank you. Thank you. Thank you.
Happy New Year, sir.
Happy New Year to all.
ಸರ್
ಹೇಳಪ್ಪ.
ಸರ್ ಫಿಫ್ತ್ ಸೆಮ್ ಅವ್ರನ್ನ ಕೇಳಿದೆ ಸರ್, ಅವ್ರಿಗೆ
ಹಾ.
ಬೆಳಗ್ಗೆ ಏನೋ ಇವೆಂಟ್ ಇರುತ್ತಂತೆ, ಸೊ ಸಂಜೆನೆ ಮಾಡಿ ಅಂತ ಹೇಳಿದ್ರು ಅವರು.
ನಾಳೆ ಸಂಜೆನಾ?
ಸರ್
ಆಯ್ತು, ಹಂಗೆ ಮಾಡಬಿಡು. ಸರಿ.
ಸರಿ ಸರ್, ಓಕೆ, ಹೇಳ್ತೀನಿ
Okay.
ಸರ್.
ಓಕೆ. ರೈಟ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ರೈಟಪ್ಪ.